Hello everyone. Today we shall discuss about Archimedes principle and the laws of flotation. First of all, we know what is Archimedes principle. Archimedes principle states that the upward buoyant force that is exerted on a body immersed in a fluid, whether fully or partially, is equal to the weight of the fluid that the body displaces. Archimedes principle is a law of physics fundamental to fluid mechanics. Now, we will read the laws of flotation. Now you see, we will find the laws of flotation. In laws of flotation, there are three conditions. What is that? The three conditions are: suppose W1 is the weight of the object in air and W2 is the force of buoyancy. In this case, there are three cases involved. Case 1. Again, I am telling you that suppose W1 is the weight of the object in air and W2 is the force of buoyancy. If the weight of the object is greater than the force of buoyancy, then the object will sink. If the weight of the object is equal to the buoyancy, force of buoyancy, then it will be float in equilibrium. That means wherever the object will be, it will float in that condition. If W1 is less than W2, the weight of the object is less than buoyancy, then it will float. I will show you two examples. I will show you how we are calculating this force of buoyancy. We will apply here two methods to find the force of buoyancy. First one is how? First one is we will find by this method that weight of the object in air minus weight of the object in water, that will be the force of buoyancy. And in second method we will apply, we will immerse an object and the volume of the liquid displaced will be measured by spring balance, the weight of that liquid. In these two methods, we can find the force of buoyancy. First of all, let us see what happens. First of all, we will find this is a spring balance, we will find the least count of this spring balance. Here you see 0 to 1 means there are 1, 2, 3, 4, 5 divisions. Means 5 division is equal to 1 Newton. That means 1 division equal to 1 by 5, that is 0.2 Newton, right? That means the least count of this spring balance is 0.2 Newton, right? Now, let us see what happens if we take an object and put it in water. First of all, let us take some water. You see, we have taken some water. And we have taken an object also. You see, this is an object. Let us see what is the weight of this object in air. Here you see, if you measure the weight of this object in air, you see, you want to measure the weight of this object in air, what happens? You see, you have taken the weight of this object in air. You see, this is 1 Newton, right? Therefore, the weight of this object in air is 1 Newton. Now, if I put it in water, then what happens? There will be loss of weight. Let us find. You see here, I am putting this object in water. And let's see the measurement of this weight. If you want to see clearly, then you can see that the reading in this case is let us see clearly what is the reading in this case in the spring balance. Yes, you see. Now we can see clearly that there are three divisions, means 0.6 Newton. You see, there are three divisions. You're trying to see it clearly that there are three divisions, that means 0.6 Newton. That means in the case of weight of the object in air, we are finding it 1 Newton. You see, here we have found it the force of buoyancy. Here you see, that is weight of the object in air is 1 Newton and weight of the object in water is 0.6 Newton. Therefore, the force of buoyancy is 0.4 Newton. The force of buoyancy is 0.4 Newton. Therefore, in this case, here you see that W1 is the weight of the object in air and W is the buoyancy. In this case, the weight of the object is greater than the buoyancy because the weight of the object is 1 Newton and the force of buoyancy is 0.4 Newton. Since 1 Newton is greater than 0.4 Newton, therefore the body will sink. And we have seen also that this body is sinking. You see here, if we release this object, see, this is sinking in the water. See? Right? That means if the weight of the object is greater than the force of buoyancy, then this object will sink. Now what happens if the weight of the object and weight of the buoyancy is same? In this case, if the weight of the object and the force of buoyancy is same, then the object will float in equilibrium. What is the meaning of equilibrium? The meaning of equilibrium is that is, wherever you put the object in water, it will float in that condition only. That is, the object, there will be no resultant force and the object will float in that position only, that is in equilibrium. And the third condition is if W1 is less than W2, that is weight of the object is less than buoyancy, then what happens? Then the object will float. We will find the buoyancy in another method in this case. Let us find the force of buoyancy in this case. Let us take one object and let's see what happens to this object. Suppose we have taken an object like this and try to give this in water. You see, this is floating. Now we try to find the buoyancy force of this object, force of buoyancy. First of all, we find the weight of this object in air. Let us find. First of all, we are finding the weight of this object in air. We are finding the weight of this object in air. Here you see, we are taking the weight of this object in air, right? Here you see that there are the reading of this scale here is 1 division, therefore 0.2 Newton. That means weight of this object in air is 0.2 Newton. Now we find the force of, what is the force of buoyancy of this object, right? For that we will apply another method, right? First of all, you see it is 0.2 Newton of this object. Therefore, weight of this object in air is 0.2 Newton. And we are writing in the third case, the weight of the object weight of the object in here is weight of the object. We are writing weight of the object. Weight of the object in air is 0.2 Newton. Weight of the object in air is 0.2 Newton, right? We found that the weight of this object is 0.2 Newton. Now we find the force of buoyancy of this object. How to find the force of buoyancy? We'll find it in another method. In this method, we can find the force of buoyancy. Let us take a glass full of water, right? And fill this water up to the brim of the glass. I am totally filling this glass. Right? To fill this glass of water fully. Right? Now I will measure measure the weight of the displaced liquid in this case. Here we have taken a beaker. Here you see, this is our beaker. Here you see, we have taken a beaker, right? And here reading is given, that is 10 ml, 20 ml, 30 ml, 40 ml and 50 ml, right? This is the beaker of 50 milliliter, right? Now I will dip this object in this water and find how much water it displaces, and we will weight the displaced liquid, right? In that case we will find the force of buoyancy. Here let us first of all find the weight of this beaker. Let us find the weight of this beaker. Yes, finding the weight of this beaker first. Here you see, we are weighing this beaker with the help of a spring balance, and just take the reading. Here you see, the reading is 1 division, that means 0.2 Newton. That means weight of this beaker is 0.2 Newton, right? I will find how much weight of the displaced liquid. Now I will dip this object in this glass of water, right? Now I am dipping this object in this glass of water and we'll see how much liquid it displaces. Let us find. Here you see, I am dipping this object and find how much water it displaces. Here you see, I am putting this object in the full glass of water and the liquid will be displaced and will get this water displaced liquid in this container. Let us find how much water it is. Here you see, we fully dip this object in water and we find the displaced liquid in the container, right? Displaced liquid in the container. Here you see, we have got the displaced liquid in this container. Now if we measure the displaced liquid of this displaced liquid in the container, we will find the weight of this liquid. Let us find the weight of this displaced liquid. And the weight of the displaced liquid will be equal to the force of buoyancy. Here you see, we are taking this on this beaker. On this beaker, and let us measure the weight of this liquid with the help of this spring balance. Here we find we've taken the liquid in this beaker and measuring the weight of this water, displaced liquid and beaker, and we are taking the reading. Here you see, the reading is 0.8 Newton. 4 division means 0.8 Newton. Therefore, the reading of this displaced liquid plus beaker is 0.8 Newton. Now we will find the calculation. Now you see that what we found is, see that weight of the object in here is 0.2 Newton, and here what we found, I see here that weight of the beaker was 0.2 Newton, and weight of beaker plus water, weight of beaker plus displaced water is 0.8 Newton. Therefore, buoyancy or force of buoyancy is equal to 0.8 Newton minus 0.2 Newton. That is, we are getting 0.6 Newton. Here you see, in this case, the weight of the object in here is 0.2 Newton and the force of buoyancy is 0.6 Newton, which is greater. The third case, that means this object will rise above the water and it will float. We got the 3 laws of flotation in this case, and we found also that this object is floating. You see here, this object is floating in water, right? And in this case, this object is sinking in the water. The object is sinking in the water. This is the first case, that if the weight of the object is greater than the force of buoyancy, but if here you find that 1 Newton is greater than 0.4 Newton, therefore the object will sink. Here you see, the object is sinking in this case. And in the third case, this object, that is, the weight of the object is less than the force of buoyancy, then it will float. Here you see, it is floating. And in the second case, W1 equal to W2, how we will find in the second case? For second case, you have to take water with alcohol, same amount of water and alcohol, and put a olive oil in that liquid. Then the olive oil will float in equilibrium. What is the meaning of equilibrium? Suppose equilibrium means there is no resultant force. Resultant force is 0 in upward or downward direction. That means the object will float in that position only. Suppose I am putting this olive oil in this position, then it will float in this position. It will neither go upward, neither go downward. That is in equilibrium, right? Therefore, the laws of flotation are three. Number one is if W1 is greater than W2, W1 is the weight of the object in air and W2 is the force of buoyancy. If W1 is greater than W2, the object will, if the weight of the object is greater than the force of buoyancy, then it will sink. If W1 equal to W2, that is if the weight of the object in air is equal to the force of buoyancy, then the object will float in equilibrium. And the third condition, if W1 is less than W2, that is the weight of the object is less than the force of buoyancy, then the object will float. These are the three laws of flotation. And we also found the Archimedes principle. Archimedes principle. What you say in the first case, that Archimedes principle states that the upward buoyant force that is exerted on a body immersed in a fluid, whether fully or partially, is equal to the weight of the fluid that the body displaces. Archimedes principle is a law of physics fundamental to fluid mechanics. And Archimedes also says that we feel an upward thrust or force of buoyancy when you put an object in water. You see here, if we put this object in water, we are finding an upward thrust or force. That is the force of, and that is the force of buoyancy. Here you see, if we put this object in water and release it, we will experience an upward thrust or force of buoyancy. Right? How to find the force of buoyancy? If you want to find the force of buoyancy, you have to find the weight of the liquid displaced by that object. Right? Here we have explained the Archimedes principle, also the laws of flotation. There are three cases. If W1 is greater than W2, the object will sink. If W1 equal to W2, the object will float in equilibrium. If W1 is less than W2, if the weight of the object is less than the force of buoyancy, then it will obviously float. Right? Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.